Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You're always welcome to join me live through the Zoom link, which is available both for me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon. And we are now in our 9th and final week of our 9-week course. You definitely should know what you need to submit by now, but as always, just to remind you, the support questions, the ones with the little pencil icon, are not for marking. These are practice problems. So you decide which ones and how many to do. If you're understanding a concept, feel free to skip questions. You do what's best for you. If you need more practice, let me know and I can send you more. The answers are at the back of your booklets, so please check your work to make sure you're on the right track. The key questions are the ones with the little key icon, and these are the ones to submit for marking. So please do all of these questions, showing all of your work, your steps in your thinking. This way I can understand what it is that you understand. And if you're struggling with anything, I can give you part marks and figure out how I can support you to understand. So how do you submit your work for marking? Well, there's 3 ways. The first way is to scan and send your work in electronically. If you have a device, a smart device, you can either scan it through an Apple device with the Notes app, or Android devices have a Google Drive app. These are free apps that generally come with these devices and are fairly straightforward to scan. If you'd like to learn how to scan your work to make your files slightly smaller and easier to manage, I have tech tutorials on my YouTube channel, which will walk you through step-by-step how to do this. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location at 74 Front Street, with a bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Sometimes when things get faxed here, they get lost in the shuffle. I'm not sure exactly how, but it's always a good idea when you send a fax. If students decide to send a fax, that's fine. Just send me an email or call me or something to let me know that you've sent it so that we make sure that we find it. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So you can find me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after airing. Also on my YouTube channel, there are short videos that explain common errors and confusing concepts. So this is a really good place to go if you are struggling with something and you need a little bit of support and you can't get a hold of me, it's outside of my working hours or something like that. It's a good place to go first before doing a general online search, just because it narrows things down already. Math is a really visual subject, so I strongly encourage you to access the videos, either joining me live through Zoom, though you may not talk to me, that's fine. Just watching is totally fine. Or watching the replays on YouTube is really going to set you up for the most success. If you can't access either of those because you don't have reliable internet or something like that, let me know and I'm happy to send you a copy of the videos so you get the full experience. All right, if you have any questions or concerns, please contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook, again, is B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. So please get in contact if you need support. All right, we are in our final week, and that means we are doing some final review to set you up for your culminating project. So today we're going to look at Unit 1, which is a lot of polynomials and factoring general review. But first, let's activate your brain with some mental math. I don't believe in mad math minutes. They cause stress and anxiety and don't teach people actual skills. So we don't do those. Instead, we develop strategies that you can use in various situations that set you up for success. All right, today's question is 397 plus 84, and we're using the strategy of compensation. Compensation is when we take from one and we compensate to the other, we give to the other. So we have 397 plus 84. So to me, whenever I see 7, I want to turn that into a 10. So I'm going to compensate by taking 3 away from 84 and adding 3 to 397. If I add 3 to 397, I now get 400. And if I take 3 away from 84, I get 81. So 400 plus 81 is 481. And that's how compensation works, and can work really smoothly like this. It can be potentially a little bit more tricky, but generally it's a way that I often do this when I'm doing mental math and doing addition, is I move my numbers around to make my numbers friendly. All right, so we want to talk about the final assessment just so that you know what to expect. This is really important so that you know what you're getting into, because it's a little bit different. So our final assessment is not an exam, but a culminating assignment, as many learning centers are not yet open, or getting into them can be challenging with folks having to isolate or life just happening. So instead, we are doing a culminating assignment, which means you can take it home. You don't have to be in the learning center. It still covers all of the 20 lessons, so it covers the entire course material. It's an open book assignment, so that means that you have access to your assignments, to the YouTube videos, to your IEL booklet, to any Desmos or virtual manipulatives, anything that we use that's online, anything else that you might use yourself, a calculator. You can use all of the tools. It is not timed, so it's not like you just have 2 hours to do it, but you will have a deadline. It's not like something that you can have it for a month. Most likely you'll get it for about 2 weeks or something like that, and we'll touch base in terms of what is a reasonable deadline for each individual student. The structure will likely be unfamiliar. It is different than our key questions. It isn't just a regurgitation of the same thing that we've already done. It's a little bit of needing to do some creativity, do some abstract thinking. It is a little bit challenging, so you do need to give yourself time, because it's not something that you can just knock out in one sitting in 2 hours. Because it's open book, meaning that you have access to all of your tools, means that you have to be a bit more creative, and it is a little bit more time consuming. So just be aware of that when you are planning to do it. All right, so let's look at lesson 1, which is transformations of quadratic functions. All right, and we need to go through this fairly quickly, just because there's a lot of information to cover today in this whole unit 1. So a reminder that when we're talking about quadratics, we're talking about the parent function, which is y equals x squared. That is our basic, our standard quadratic. And then every other quadratic is based off of that quadratic. It's transformed, it's moved, or compressed, or stretched, it's flipped, it's that, it's reflected. This is how we get all the other parabolas, by modifying y equals x squared. So the general form of our parabolas, of our quadratics, is y equals a times x minus h to the exponent 2 plus k. With a reminder that for our parent function, a equals 1, h equals 0, k equals 0. And that's how we get y equals x squared. So this is our base function. But then we dove into figuring out how we changed our general formula to make all the other parabolas. So first we looked at k. And so here, if we have a parabola that has been shifted up, we've added 5 to each, we added 4 to each of the points. And so k is equal to plus 4. So our formula is y equals x squared plus 4. Our a and our h are still the same as they were before for our parent function. Then in the second parabola, we can see our whole parabola has shifted down -7. So our k is equal to -7. And our new formula is y equals x squared minus 7. And that's how we get this parabola. So k is a vertical shift, is what we call it. So if you have a positive k, it's greater than 1, so greater than 0, it shifts up. If we have a negative k, it's less than 0, then we shift down. All right, then h is the next one that we examined. And here, looking at h, we can see our parent function is this red function, this green, all of our values have been shifted to the right by 2. So our h is positive 2. But when we put that h value into our formula, this is the tricky one because our base formula is a times x minus h. So if we put in that plus 2, we're doing x minus positive 2. So that means that our formula looks like y equals x minus 2 all to the exponent 2. This is confusing. This is tricky. If you go back to lesson 1, our video on lesson 1, which will be linked in the show notes, then you will see how we get that, why that makes sense. If it doesn't make sense to you and you just want to memorize it to get it through, then you can remember that h, the sign is opposite than what you expect. Here's our second example. We have shifted our parabola to the left by 6. So -6 is each of our values. H is equal to -6. So then if we have x minus -6, that means that that actually turns into a positive. So our formula is y equals x plus 6 all to the exponent 2. So h is a horizontal shift. A positive h greater than h greater than 0 shifts it right, and a negative h shifts it left. But remember, what's going to look like in your formula is going to be opposite what your h value actually is. So that is super, super important. The h sign in the equation is opposite than you're likely to expect. So this is a tricky one. All right, and then we have 2 parts to examine for a. So the first part, when we're looking at the a, is here our parabola has been squished. We are now narrower than our parent function was. And here our a is equal to a value of 3. Each of our points have been multiplied by 3. And so we've stretched it vertically, which means we've made it narrower. So here that would look like y equals 3 times x squared. We have a value of 3. We're multiplying each of our values by 3. Then if we do our second example, we have our new parabola is wider. It's been squashed down. And so here our a is equal to 0.5. So all of our values have been cut in half. So y equals 0.5 x squared. So a is a vertical stretch. So if a is greater than 1, then it is narrower. You are stretching it, and therefore everything is becoming narrower. If a is between 0 and 1, then it's becoming, your parabola becomes wider. It's like you're pushing it down, you're squashing it. So then part 2 of looking at a is if our a value is positive. So here we have, I've moved both my my h and my k values, as well as looking at my a. Sorry, my animations were poorly done there. I got mixed up. My A value is positive in this first example where my parabola is orange. And so we're opening up we don't have a number necessarily in front of our brackets because it's just one, so one disappears, but it's just a positive value. So that's just telling us that our parabola is opening up. Our second example where our parabola is blue, then we can see that our A is negative, and so now our parabola is opening down. So that we end up with y equals negative x squared, which this negative value in this negative symbol in front of the x squared tells us that we have a negative reflection and we're opening down. So A value is a vertical reflection as well as a vertical stretch. And if you have a positive A, then it opens up. If you have a negative A, then it opens down. All right, so let's do a little bit of practice to actually apply what we've just been talking about. So number one, identify the A, H, and K values, then graph these parabolas. So in part A, we have y equals 2 times x minus 3 to the exponent 2 minus 4. So we're looking for our A, our H, and our K values. It doesn't matter what order you do these in, you just need to know which ones actually represent which. So here A is equal to 2, which means that it's a vertical stretch. So I'm just going to say that it's narrower and opens up. H is equal to, here it says -3, which means that it's +3 because H is the opposite what we're expecting. So we're going to shift right by 3. And K is equal to -4, which means we're going to shift down because it's negative by 4. So when we are graphing this, how we do it is that having your parent function, a rough approximation of your parent function, helps so that you know what you're doing. I should have made that red to be consistent. Let me try that again. Okay, so this is our parent function, just so that we know where we're starting from. It's not perfect, and I'm going to label it so that we know what it is that we're talking about. Then going back to blue, we want to shift all of our points. So we know that it's narrower than this parent function, and we know that it's opening up, so it's still opening the same direction. We know that we want to shift right, so I'm going to just shift my vertex. I'm going to shift it right by 3, so 1, 2, 3. And then I'm going to shift it down by 4, so 1, 2, 3, 4. So my vertex is now starting here at this point at +3, -4. And I know that I want it to be narrower than my other parabola, but I know that I still want it to open up. So because we're just sketching, then we don't have to make it exactly. That's okay. For our purposes, we are just sketching. We don't have to plot the points exactly right. Again, we want to label it so that I know what it is that you're talking about, and I know that you know that what it is that you're talking about. Okay, so now let's do part B. Y equals negative times x plus 5 to the exponent 2 plus 1. So we're looking for our A, our H, and our K. In this case, our A is -1. We don't have a number, but if we don't have a number, that means that it's 1. Our H is -5 because it's +5 in the equation, so it's going to be the opposite. And our K is +1. So -1 means there's no shift, but it opens down. Sorry, it's no stretch or compression, but it opens down. A negative H means that we're moving left by 5. And a positive K means that we are moving up by 1. So again, I'm going to still start at on my parent function, but now I'm opening down instead of opening up. I'm moving to the left by 5, so 1, 2, 3, 4, 5, and I'm moving up by 1. So I'm going to start at -5, 1, and this time I want my parabola to be roughly the same shape, but I'm opening down this time. And so my parabola would look something like that. Again, rough sketch is fine, but we want to label it. And that's how we use those values to graph or sketch a parabola. All right, number 2, the height of a toy rocket launched from the top of a building is given by the equation h equals -5 times t minus 3 all to the exponent 2 plus 145, where h is the height of the rocket in meters after t seconds. Sketch the path of the toy rocket. So because this is just sketching, I'm just going to give myself an axis, and I'm going to say, okay, well, it's negative, so it's going to be opening down. It's -5, so it's going to be wide. I'm starting at moving over 3 seconds because A is equal to -5, so that tells me opening down and it's wider. H is equal to +3, so that means I'm shifting right 3. And K is equal to positive 145, so I'm shifting up 145. So this is how I know I'm shifting my parabola over 3 to the right and then up 145. It's okay if our scales are different, that's fine. And then I'm opening wide and I'm opening down. And that gives me a rough idea how my toy rocket flies. It goes up and crashes down, which looks like what makes sense. So what is the maximum height of the rocket and when does it occur? Well, the maximum height, the highest that it goes, is 145 meters. And it reaches it occurs, or it reaches it at 3 seconds. What is the initial height of the rocket? So here we're trying to figure out when does it hit our y-axis? So that we would have to do when h in our equation is equal to 0. No, that's at t seconds. Sorry, we're looking for h. My bad. This is when time is 0. That's our initial height. Well, where do we start? So we would put h is equal to -5 times 0 take away 3 squared plus 145. So 0 take away 3 is -3, squared is 9 times -5 is -45 plus 145. So 100 meters is how the initial height of the rocket. And then what is the height of the rocket after t equals 7? So t after 7 seconds, we do the same thing where t is equal to 7 and we find the same thing. I'm not going to do it just because we have lots to do in this lesson and I'm already running behind, but that is how you would answer that question. All right, lesson 2, let's dive into polynomials and factoring. So the first part about this lesson, we looked at multiplying binomials, which also could be called expanding binomials. So we used algebra tiles, which is, we walked through what algebra tiles mean and how we would lay that out so that they would give you a visual understanding. We also use the box method, which is where you use numbers instead of using algebra tiles, but you are sort of representing it in the same way. Or we used FOIL, which is how it talks about in your IEL booklet, but I didn't go into too detail on our lessons, which is when you do first, outside, inside, last. Again, all of these things I'm just mentioning because we are reviewing, but we don't have time to go into detail. If you need to go into detail, go back to our lessons. Then we did factoring, which is we used algebra tiles for. So we remember that we common factor first if we can. In this example, we have a common factor of a, so we factor that out first. Then we have our double set of brackets because we're looking for two binomials that multiply to be this trinomial. Then our square term is the term that goes in the first spot. And we're trying to figure out what multiplies to be the constant and that two numbers. So we find all of the factor pairs that multiply to be that constant value. Remember, both positive and negative numbers count. And then which of those factor pairs add up to the coefficient of the middle term. And so that those two numbers then are going to be our second two terms in our brackets. So they go in the second spots. Again, just briefly ran over it. It doesn't make sense. Go back to lesson 2 videos, and it was a long video. I broke it up into 2 parts, and so it's hard to squish that into one in about 3 minutes. Okay, let's do some practice. So we're going to expand the following. So A, I'm going to use the box method first for part A. I'm not going to use Algebra Tiles just because they're time consuming, but you can totally use Algebra Tiles still. So this is x plus 12 along the top and x minus 3 along the bottom. And then I break my box into the parts. So I know that I have to do x times x, which is x squared, x times 12, which is 12x, negative 3 times x, which is negative 3x, and negative 3 times 12, which is negative 36. So then we take all of those parts and we combine them. So x squared plus 12x minus 3x minus 36 is equal to x squared plus 12x minus 3x is going to be 9x minus 36. And there we go. We got a trinomial. For part B, we have 4 times n minus 5 times n minus 8. So this is tricky because we have a value in the front. We need to remember that when we have this value in the front, we need to do it just to 1, and then whatever we have left, we multiply it by the other. So I'm going to do using FOIL this time, but I'm going to multiply my number 4 into my brackets of n minus 5. So 4 times n is 4n, and then 4 times negative 5 is negative 20. And then my second bracket is still n minus 8. So now again, I'm going to do FOIL. So I do my first times my first. So 4n times n. Then I'm going to do outside. So 4n times negative 8. Then I can do inside, negative 20 times n. And then I do last, negative 20 times negative 8. And I'm adding these all together. I put everything in brackets, so whatever, I'm going to figure out my signs as I go. So 4n times n is 4n squared. 4n times negative 8 is negative 32n. So now I have 4n squared minus 32n. Then negative 20 times n is going to be negative 20n. So I'm subtracting another 20n. And then negative 20 times negative 8 is going to be negative 160, except it's not, it's positive 160 because negative times negative equals positive. So then I have 4n squared minus 52n plus 160. And that's how we would expand that. All right, number 4, let's factor. So A is x squared plus 5x equals 6. So I'm looking for two numbers that multiply to be 6 and add to be positive 5, positive 6 and positive 5. So my factor pairs are 1 and 6, negative 1 and negative 6, 2 and 3, because 2 times 3 equals 6, and negative 2 times negative 3. Negative 2 times negative 2 equals 6. Which one of these add up to 5? Well, 2 plus 3 is equal to 5. So that means that in my brackets, we have x in the first place, and then we're going to have plus 2 and plus 3 in our second places. And that's all you have to do with factoring. Factoring is really, there's not a lot of steps that you write down necessarily. You can do all of this part in your head if you wanted to, that's fine. But that's the thinking that we're going to do. For this second one, I have a coefficient of 4. So I have 4x squared minus 8x minus 32. So I need to factor that 4 out first. So if I factor 4 out of negative 8x, I get negative 2x, because 4 times negative 2x gives me negative 8x. And if I factor 4 out of negative 32, I get negative 8, because 4 times negative 8 equals 32. So now I'm looking for two numbers that multiply to be negative 8 and add to be negative 2. So I'm going to have my two brackets, and x still goes in my first spot. But my factor pairs, what are my numbers that multiply to be negative 8? Well, negative 2 and positive 4, positive 2 and negative 4. Which I can see right away that negative 2 plus 4 is going to give me, no, positive 2 minus 4 is going to give me negative 2. So that's going to work for me. So I have plus 2 minus 4. And that's how we do that. Okay. Lesson number 3. Recognize, so this was solving and graphing quadratic equations. So we're going to recognize the zeros on our graph was the first thing that we did. So we have a parabola, y equals x squared minus x minus 12. So we did a table of values to figure out where our zeros were. And then we plot our graph. And we can see that where our parabola crosses our x-axis, these are called your x-intercepts, or they're called your zeros. These are where y is equal to 0. When you put a number into your equation, you get a result of 0. So the zeros for y equals x squared minus x minus 12 are x equals negative 3 and x equals 4. Those are the two places that our parabola crosses our x-intercepts or x-axis. So if we are solving a quadratic equation, we can use factoring. We don't just have to graph it. So this means, remember, when we're solving a quadratic equation, what this means is that we're solving a quadratic equation by finding the x values that make y is equal to 0. Then when we're factoring, this means that we're finding the terms that multiply to be our product. So those are the two tools that we need to use. So we have y equals x squared minus 10x plus 21. So we do our step 1 first, which is like what we just did. We're trying to figure out where our values of 0, we want to make this equal to 0. And that's going to be what we're trying to figure out. So we first set our equation to equal to 0. And then now we need to factor in order to find our two terms that are binomials that multiply to this product. Because we remember that if we have two numbers that multiply to each other that equal 0, then one must be 0 or the other must be 0. So for step 2, we are going to factor this. Here I just did the factoring really quickly as we already talked about factoring. So we have 0 is equal to x minus 7 times x minus 3. So that means that either x minus 7 equals 0 or x minus 3 equals 0. And the only way that can happen is if x is equal to 7 or x is equal to 3. So then just wondering, does the graph give us the same answer? So looking here is the graph of y equals x squared minus 10x plus 21. And we can see that yes, our values where our parabola crosses our axis, we have that at x equals 3 and x equals 7. Okay, so practice questions. Number 5, find the x-intercepts for each parabola. So remember, our x-intercepts happen when y is equal to 0. So for part A, we have y equals x squared minus 4x plus 3. So we put in 0 for y, and then the rest of it stays the same. And then now we just need to factor. So we have our two sets of brackets. We're looking for two numbers that multiply to be 3 and add up to be negative 4. So 3 and 1 multiplied to be 3, and -3 and -1 multiplied to be 3. So -3 and -1 are going to add to be -4. So this means that either x minus 3 is equal to 1 or x minus 1 is equal to 0. Sorry, x minus 3 equals 0. So that means that x equals either 3 or x equals 1. So those are our x-intercepts. Sometimes your equation doesn't show way up you're expecting it to be. Here we have for part B, -7 equals 5x squared minus 10x minus 22. So I can't just change this -7 to a 0. I have to balance it. So I'm going to add 7 to that side in order to make it 0. If I do it to one side, I'm going to have to do it to the other side. So then I have 0 is equal to 5x squared minus 10x minus 15. So then here I can see again that I have a common factor of 5. So I factor out 5, I get x squared minus 2x minus 3, which if we factor is going to be x, want two numbers to multiply to be -3 and add to be -2. So x take away 3 and x plus 1, because -3 times 1 is equal to -3 and -3 plus 1 is equal to -2. So then either x minus 3 is equal to 0 or x plus 1 is equal to 0. So that means that x has to be either 3 or x has to be -1. Those are your intercepts. All right, lesson 4, exponent laws. So the key thing to start with exponent laws is that you have to have the same base. If you don't have the same base, either with variables or with numbers, you can't apply your exponent laws. They don't make any sense. So if we have a multiplying power rule, we add our exponents. If we're multiplying two powers that have the same base, we add our exponents. If we have a dividing power rule, if we have two powers of the same base, then we subtract our exponents. The powers to a power rule, we multiply our exponents when we have a power to another power. Our 0 rule is that anything with an exponent of 0 equals 1. So t to the exponent 0 is equal to 1, no matter what t is. Our negative exponent rule is that the negative exponent equals the reciprocal of the base. So 1 over the base. So this is always a tricky one. So if you have a to the exponent -b, this is equal to 1 over a, but now to the positive b. The negative goes away because you flipped it upside down. Nothing else becomes negative, but that negative just means that you flip it, that is the reciprocal. If you have x over y, all of that to the exponent -z, then to get rid of the negative, you have y over x now, all to the exponent positive z. That's the key. Again, I'm just reminding you what the rules are. If any of these are still confusing to you, go back to lesson 4 and break these down, because again, this was a lesson that we broke up into a bunch of parts. All right, practice questions. So let's simplify some powers. So A, we have 5 to the exponent 20 divided by 5 to the exponent 12. So that means we have 5. This is dividing, so we're going to subtract our exponents. So 5 to the exponent 20 take away 12, which is 5 to the exponent 8. If they just want you to simplify it to the single power, that's all it wants you to do. Part B, we have 3 to the exponent 4 to the exponent 7. So we have a power to a power, which means we're going to do 3 to the exponent 4 times 7, all in our exponent. So 4 times 7 is 28, so 3 to the exponent 28. Part C, we have 2 to the exponent 17 times 2 to the exponent 8 divided by 2 to the exponent -3. So we all have the same base, 2. So 17, first we're doing 2 to the exponent 17 times 2 to the exponent 8. So we're going to add those together and then divide by 2 to the exponent -3. So 2 to the exponent 17 plus 8 is 25. We are subtracting 2 to the -3, so we're going to subtract. And because we're subtracting -3, that is like we are adding, so we have 2 to the exponent 28, just to confuse you. Then finally, for part D, we have 5x to the 6th y times 4 x to the 5th y cubed. So here we combine, we want our numbers to go together. So that's 4 times 5. And then x, we're multiplying. So we have 6 plus 5 and y. If it's just y, that's a 1 plus 3. So 4 times 5 is 20. X to the 11th, y to the 4th. If we're going to evaluate powers, we're generally going to use your calculator, which we talked about what your calculator button would be. So here let's look on Desmos. So if we have 6 to the exponent, this is my exponent button on Desmos. We have a to the exponent b. Then I get to choose whatever my b is, and my calculator makes my cursor go to a superscript. It's a little higher. And then it shows you 6 to the exponent 3 is equal to 216. That's all you need to do when you're evaluating. You're totally allowed to use your calculator if that helps you. Here we have b is negative 11 to the exponent 0. Remember, anything to the exponent 0 is equal to 1. It can be negative a million, can be a million, can be a billion. To the exponent 0 still equals 1. To figure out why that is, go back to our lesson on 4 and I break it down a lot. Part C is 4 to the exponent 2, and it says to express this as a fraction. So remember, 4 to the exponent negative 2 means 1 over 4 to the exponent 2, which is equal to 1 over, and then 4 squared is 16. So 1 over 16. That's all you need to do. All right, and lesson 5, simple exponential equations. So solving exponential equations. So remember that this is y equals capital A times b to the exponent x, where b is your base. So it's any positive number except for 1. And a is a scalar. So this is any non-zero number. Could be positive or negative. If b is greater than 1, then this is exponential growth. We are getting bigger, faster and faster and faster as we increase our values of x. If b is between 0 and 1, this is exponential decay. So if it's a fraction or decimal, then we are getting smaller and smaller and smaller, faster and faster and faster. When a is equal to 1, all exponential graphs will go through 0, 1, because anything to the exponent any b to the exponent 0 is going to equal to 1. So it's always going to be going through 1. And it doesn't, no matter what, exponential equations do not have x-intercepts. Y can never equal 0. It doesn't make any sense. It's not possible. So it always is going to be above the x-axis. Okay, so then we talked about doubling times and half-lives, because these are the two sort of most frequently discussed examples. So doubling time is that it takes a time. So doubling time is referring to the time that it takes for a quantity to double in size. So this is the base formula, which is P equals P0, which is like the P sub 0, times 2 to the exponent T divided by D, where P is your final quantity, P sub 0 is your initial quantity, how much you start with, T is your time, D is your doubling time, and the base is 2 because it's equal to doubling. If it was a 3, then it would be the time that takes something to triple. If it was 10, then the time that takes something to be a multiple of 10, or be multiplied by 10. No, it'd be 10 times its size. There we go. For half-lives, it's the time that it takes for a quantity to decay to half its original amount, so cut in half. So this is represented by m equals m sub 0 times a half for your base, which is to the exponent t over h. So m is your final quantity, m sub 0 is your initial quantity, t is equal to your time, h is equal to your half-life, and the base is 1/2 because it's a half-life. So again, if it was 1 over 3, it'd be a third life. If it's 1 over 4, a quarter life. 1 over 10, it would be 10th life. Okay, so looking at an example, number 8, choose the graph from the grid that best represents each relation in the list below. write your choice beside each equation in the list. So we have a graph that has A, B, C, and D for exponential functions on a graph, and then I have y equals 0.8 to the x, y equals 5 to the x, y equals 1.75x, and y equals 0.02 to the x. Which one of these match with these? So the first thing that I'm going to look at and say, okay, well, y equals 0.8 to the x is going to be decay because it is less than 1. And y equals 0.02 is also going to be decay because it is less than 1. And so y equals 1.75 is growth. And y equals 5 to the exponent x is also growth. So that helps me to narrow down my A and B are both decay and C and D are both growth. So that just tells me a little bit more. So then I have to think about, if my value is closer to 0, does that make it steeper or shallower? So I think about this in terms of, I know what sort of one, if it's doubling versus if it's doing the 10th. So the bigger value when I'm growing, the bigger value makes it grow faster. So that means that y equals 5 to the exponent x is going to be C, because C grows faster than D does, and C has a bigger base than, y equals 5 to the x has a bigger base than y equals 1.75 to the x. So that's going to be D. So then the same with A and B. Now this one, it's, again, the faster it's going to go is going to be, this is what I always get it backwards. So it's the smaller the fraction, the longer it's gonna, the slower it's gonna decay. The smaller fraction decays slower. So y equals 0.02 is A, and y equals 0.8 to the exponent x is B. If I got that wrong, feel free to let me know. But this is why it's important to think about these things in terms of what makes sense, and they can be tricky, easy to make mistakes with. All right, number 9, 100 rabbits are introduced into a forest-covered island. The population doubles in number every 6 months. Make a table of values with 5 rows to find the population of rabbits over time and graph the relation. So we got to figure out our formula because they don't give it to us, but we can do this. So we have, I'm just going to say y equals, we're supposed to do p equals p0 times 2 to the exponent t over h, right? So p equals 100 because that's our initial amount of rabbits. 2 is still 2. Our time we're going to figure out, and our half-life happens, it's every 6 months, which our time is in 2. So our time is in years, so it would be our every 6 months. Oh no, because our n is equal to 6. So divided by 6. Trying to figure out if that makes sense. So when n is equal to 0, we have 100. N is our time. So that's going to be 0, that's going to be 1. When n is equal to 6, we're going to have p 100 times n to the exponent 1, which is going to be 2. There we go. Yep. When n is equal to 12, we're going to have 100 times 2 to the 12 over 6, which is going to be equaling to 400. When n is equal to 18, it's going to be 800. When n is equal to 24, it's going to be 1,600. And that's, sorry, when n is equal to 30, it's going to be 3,200. So our graph is going to be big enough to do all that. So when n is equal to 6 rabbits, there were 6 months, there were 200 rabbits. At 12 months, there were 400 rabbits. At 18 months, there were 800 rabbits. At 24 months, there were 1,600 rabbits. And then we can graph that to show how our rabbit population increases. So here, part B, it says state the p-intercept of the graph. So where does our line intersect our population? At 100, right? That's how much we started with. After how many months would the population be 550 rabbits? So we can look approximately, that's halfway between 500 and 600. That's approximately here. So at about 14.5 months. Describe the type of relation in the graph. So this is exponential. As we are growing rapidly, we're doubling in time. It's a doubling time. Okay, and that is our intense review of Unit 1. Again, we just blew through it. It was a lot of information. So if you have any questions or you're unsure about anything, you need to review anything more, obviously you should review things more. Go and check out our YouTube channel that is B-Slate Wahsa. There's a playlist called MBF3C. All of our lessons are there, so you can go review at a slower pace. Today was just a pack it all in and remember what we've done this year. If you have any questions, give me a call at 807-737-1488, extension 2209, or call me toll free at 1-800-667-3703. Send me email at bronwyn.slate@nnec.on.ca or a Facebook message at bslatewahsa. My office hours are Monday through Friday, 9 a.m. to 3 p.m., although I teach the last hour of my day, so that is not a good time to try to get a hold of me. If you, as always, please reach out. I'm here to support you. That is my job. Thank you so much for joining me. I hope you have a great day. Miigwech.